Hi, this is David Bernick for the Data Security Working Group. Uh, my friend and my colleague JP and I will be presenting today. So I'll do the first parts of these slides. So the AAI, the authentication specification, has gone very well this year. We've had a lot of adoption across some very large, big projects, mostly because we collaborate very closely with the Dury Group and their passport specification. In fact, if anything, AAI is an enabler of the real power of the Dury passport specification. We're all very, very proud of that. The NIH, for instance, is adopting it as part of their RAS project, which is going to be wide across the entire NIH. And that's really, really interesting. And we are very happy at how that's going. We've gotten feedback because of that, and it's good feedback, and we are working that back into the specification. But again, a lot of the things that we're doing are really there to enable passports. That is the driver of this. And whatever they say is essentially what we help them with, so long as the security is intact with it. And the passport really is the strong driver here. Another effort that we have is the DSIP. The DSIP is a sort of framework of security practices that people can have if they're data stewards or data controllers, data processors, or even software builders. And the idea is to give people who are building software something to look at that will help them understand what they have to do to be secure. Now, the DSIP, as it stands right now, is fairly loose in comparison to more traditional frameworks like ISO and NIST, which are much more prescriptive. The idea that we have right now, and it should be done by the time this meeting takes place and by the time you watch this, is that we're going to have a matrix that aligns the DSIP stuff to a more traditional framework like ISO and NIST. So people can read the DSIP, and if they have to work for an organization or do some work that has to be aligned to these more traditional frameworks, they can do so pretty easily and show how they align to it. They can also know what gaps they have if they follow the DSIP directly and they look at these traditional frameworks and say, oh, if I'm going to follow this traditional framework for some other project, these are the things that I'm missing. So the idea is to give people what's called a matrix, which is pretty commonly used in security, to understand what is covered by the DSIP and what is covered by industry and where those gaps are. Another part of the DSIP that's helpful is once we have that matrix, we can start building some automation. So the next feature of this in the next year deliverable is to create a bunch of tooling or adopting open source tooling or giving guidance on how people directly can in fact align to more traditional security frameworks and use the DSIP as guidance and automated tools they can use to actually fulfill a lot of these things. So to make it a little bit more prescriptive, if only by means of suggestion, as opposed to telling them this is what you have to implement.
All right, now it's JP speaking. So let's move to the next deliverable. This one is about federated cohort exploration and analysis. So the purpose is to enable analysis, so typically machine learning operations on medical data sets that happens to be decentralized while respecting the patient's privacy. This is particularly relevant in considering the evolution of the regulation framework and especially the consequence of Schrems 2 that is going to make the transfer of data from the EU to the rest of the world more difficult. So on this topic, we are talking and collaborating with the I2B2 and the Odyssey community on common data models. And we have developed a complete technology to support computation on encrypted, partial aggregated results. We are applying also this technique to COVID-19 data in the framework of an international collaboration called the SCORE, Secure Collective COVID-19 Research Project. The use cases are about drug efficacy, readmissions, disease evolution, and genetic dimension. So on this topic, we collaborate, surprise, surprise, with Swiss Personalized Health Network, our domestic and yet of international relevance driver project, and talking also with a few more. About now, the next one is the cloud security and privacy. So what we are doing here is to develop the guidelines, recommendations for secure and privacy conscious use of the cloud services. We have had good discussions with cloud colleagues, And we have elaborated the first draft version of the Cloud Security Technology Framework. It is online. Please do provide feedback. We would like to wrap up this document by the end of this month, actually. And we are collaborating on this topic with the regulatory colleagues, notably in addition to the cloud colleagues. Last slide is about the longer term deliverables. So these are the topics on which we are currently not working that much, but we still have them on our radar. The first is about malfeasance rules. This is a topic on which David Burnick is particularly, let's say, interested. Here, the idea is to try to identify patterns of queries generated by researchers that make it possible to identify malicious behavior, and notably the presence of potential re-identification attacks. The second one is a blockchain for query recording. This is meant to be a kind of a deterrent in the sense that data about queries are immutably stored on the distributed ledger in such a way that they can be used a posteriori to carry out an inquiry if needed, if something goes wrong. Okay, that's it from my side. Thank you very much.